Welcome to the ASN channel. Now let's design the LED blinker PCB using KiCad software. So first you need to go to file and click on new project, and it will ask for the file name. Give the file name. I am giving the LED blinker and click on save. You will be appearing two icons like this. One is the schematic and second one is the PCB. First we need to select schematic. In this schematic we will design the circuit here. Okay, and now the schematic editor will be open like this. Here you can see a lot of icons and windows that are present. First, in order to design the circuit, we need to place the components on the schematic editor. Okay, for this you need to click on the place symbols. Okay, and it will load all the libraries as well as the footprints assigned for this project. So it will take 30 to 40 seconds to load all the symbols. So we need to wait until it completed. Yes, after loading completion, we will get these symbols window, and by giving symbol names in this filter box, we can place the components. So first we will see what are the components that are required to design the LED blinker. This is the schematic creation of LED blinker. The circuit consists of very simple circuit. It consists of three components. One is the battery, and second one is the resistor with 470 ohms, and third one is the LED. And after completing the creation of the circuit, we will go for the simulation. Here in this simulation, this is the PCB layout of the LED blinker, and this is the PCB artwork of LED blinker. Based on this artwork, we will do all the etching and drilling process for hardware development, and finally we will be appearing the physical LED blinker like this, and this can also be seen in the 3D viewer in the KiCad software. So now let's dive into the software and complete all this process. So go to the schematic editor. First we will place all the components here, the three components. The first one is the resistor. For this you can click simply capital R in this box, such that the resistor will be appear. Select this resistor and place here. So before placing the component, you can change its direction by clicking R in the keyboard. Okay, if you press R, it will rotate. So as per your convenient, you can place this component. I am placing this component like this here and click on escape. Okay, now select one more component. So for selecting component, you need not to go to this symbol and always click on this symbol. You can directly click A key on the keyboard. It will open. Okay, the symbols window will be open. And now uh, one more component is the battery. So give the words, that is battery. Here you will be having the single cell battery and multiple cell battery. Select multiple cell battery, click on OK, and here place it near to the resistor. Okay, and again click on escape and select one more component by pressing A in the keyboard. And the one more component we want is LED. So select LED, and before placing the LED you can rotate by clicking R on the keyboard and place this here. Okay, now you can zoom these objects by clicking on the icon zoom to objects, so you can see the objects very clearly. Okay, now you can drag the components wherever you want by selecting the component, and you can drag this component. So now placing the component is over. Okay, Now we need to connect by using a wire. So for this you can use the draw wire, and by using draw wire you connect all the three components like this. Components are connected, and we need to assign values. Okay, for assigning the values, click on the battery, click on the battery or components. Here you need to give the values. So here select 9 volts battery, you can give simply 9 also, it will work. And the resistor value is 470 ohms, the value 470, and the LED is it okay. Okay, now the placement of component as well as the assigning values are completed. Now we need to assign the footprints for this component. Okay, for assigning footprints you can go for this icon here, assign footprints, click on this, and it will load all the footprints. And if you see here in the middle, it will list all the components that we are used here, that is BT1, battery, LED and resistor R1. So for this we need to select footprints, appropriate footprints. For battery you can go to connector pin header 2.54, left side, single click on it, and go for fourth one, that is double click on it, that is P 2.54 mm vertical. And for diode also go for LED. Here you can see two, surface mounted device and through hole technology. We will be using through hole technology, so that's why click on LED THT and select LED 5.0 mm, it will be okay, double click on it. And now select for R1 also you can select THT, through hole technology, and here you can select this 21st one, that is horizontal. Now assigned footprints is completed, you can save to schematic, and after saving you can close it. Okay, now you need to check the ERC once before moving to the PCB whether any errors are there or not. So run ERC. Here errors should be 0 and warnings also 0, so we can move to the PCB design. Click on switch to PCB editor. Now PCB editor screen is appear, and go to tools and update PCB from schematic. Click on update PCB from schematic. Update PCB. Close, and you can drag it and place it here, and you can zoom. Click on zoom to objects. These are the components that we designed in the schematic. Now in order to overcome the overlap, we need to place the components properly. For this you can select this component and drag this side, and you can place this component this side such that you can rotate this resistor as well, and you can drag this like this. You can zoom less, and now we need to draw the tracks for this. If you observe here you can see the blue lines, wherever the blue lines are there you can draw the lines for this. You can connect, and from this to this, and from second pin to second first one. Yes, now tracks also completed. So before going to print preview, Draw one rectangle. Okay, now PCB design is ready. You can see it in 3D viewer. See, this is the physical appearance of the LED blinker after designing the PCB. And for etching and drilling process, I will show how to take the printout. Go to new, select print. Here front copper means we are placing the copper on the front side. For single layer PCB and F dot silk screen without components or with components, we will use this silk screen. Select F dot silk screen and also the edge cuts. Okay, click on the print preview. Finally, your LED blinker PCB design is ready. You can cut this area of the small area of this paper and you can go for the PCB fabrication. Okay, for hardware. Thank you.